Okay, finally, we got parts in. The crankshaft came back, and it took a while. Everything takes a while when you're talking about engines like these because everything's got to be made. And there's people that do it. It just takes a while. 2-3 months is just the norm. I've got 3 of these engines in right now for build, and this first one is getting underway for assembly right now. But what we did with the crankshaft, this is an SS crank. Obviously, the 3-liter standard SM crankshafts do not have additional weights here. And the rod bearings are oiled via a different mechanism. The SS oils them, I think, and others have postulated that it's because of what Alfieri learned from racing, that he had to change the way the SS cranks oiled the rods. But still, these particular engines have an absolutely massive oil pump on them. The oil pump is essentially the same size as the V8 engines because it's a little gear driven, and I'll show it to you in a minute. And it goes through this giant oil gallery here, and it feeds the jack shaft here, and there's another spot down there. It feeds the jack shaft, and it goes along, and it feeds the main bearings. And, the problems sometimes were with these final, this is the journal for cylinders number 1 and 6, that you'd see more wear on the 1 and 6 bearings because it was all the way at the end and the oil was all the way coming from over here. But I haven't seen that bad of issues with these. But then again, I've never seen one of these engines with really huge miles on them before. So yeah, there's that. But some people notice that these do not have piston oil squirters on them. And I don't think they're needed for these because if you look all the way down there, that is a passageway that comes from the jack shaft. You can see it. The oil just drips straight down from the jack shaft. And all of that is being splashed around by the rods. And it's being splashed onto the underside of the pistons. I just think it would be overkill for these if they had piston squirters as well. I mean, I think you could, but in the performance variants of these engines that I've built, as well as the racing engines that were built in period, they never used piston oil squirters. And I haven't seen issues with these. So anyway, the crank is spinning nicely. The journals for the rods, in order to gain the additional stroke that I have on this engine, they gained 7 millimeters of stroke. These rod journals were taken down to 50 millimeters. I believe the stock is 57 millimeters. And when they offset grind the crank, all they're doing is removing material from everywhere except for the back side of the crank. And that way, reducing that overall diameter gives you an increased stroke. But this crank turns nicely. They straightened it, they re-nitrided it. And as I said, I had 3 of these done all at the same time there. And they do a beautiful job. I get these done by Marine Crankshaft in California. The other issue Maserati went through with these engines, because it is an inherently imbalanced engine, like 4-cylinder engines, for example. Those are all imbalanced as well. Is you can balance them with the counterweights and have a primary balance, but an odd fire V6, like a 4-cylinder engine, it has a secondary imbalance, and that secondary imbalance is not something you can ever get rid of. And a lot of modern engines are now 90-degree V6 engines because the quality of components is so much better. I'll show you. This is an SS connecting rod. Maserati made 3 or 4 different variants of this connecting rod because connecting rods were a weak point of these engines, and they used an absolutely massive 24 millimeter pin as well on them. And they beefed it up right around here. The variants were usually thicker right here. And they had to do that because the secondary imbalance of them, they didn't want these things flying apart under warranty period or something like that. So, but now with modern components being what they are, that's a thing of the past. 90-degree V6s, odd fire, are normal now. The Alfa Romeo Quadrifoglio is 90 degree odd fire V6. And the new Maserati Nettuno engine is 90 degree. Who would have thought Maserati would make one again? But they do. And they stuck with that design because they could have gone even firing, but to go even fire with 90 degree, you have to have a split pin crank here, like Buick did. And that just results in less bottom end strength. And so they said, well, with modern forged connecting rods and pistons, it's not a big deal. So it's not. The old stuff that was cast is just, yeah. So anyway, whenever the block has been bored as well, to 92 millimeters. When you bore these blocks, you have to use torque plates. You have to, because you get distortion on the cylinders over here, okay? Specifically, the middle cylinder is what I've measured anyway. It measured out a good almost thou out around after the torque plates were torqued on. And you also have to torque up the bottom to really get it nipped up and check it appropriately. Now, that's something the factory never did from new, and they did run fine from new, but you know, if you want it to be right, you want it to be right, and that's just that. A lot of Ferrari engines, you see it the same issue, especially with the flat 12 Berlinetta Boxer engines. If you don't use torque plates on those, they're really out of round. You know, again, they ran fine when new, but just when you're rebuilding them now, you might as well do it with torque plates and just have it done right. But yeah, the new components that I had made for this, the rotating components, are so much lighter than the stock components that they removed, like, it was almost a pound of weight or so off this crankshaft. I can't remember the exact number, but they removed all kinds of weight to get the primary balance where it needed to be with this, just because so much weight was removed, which that's a good thing. We like that. These cranks, the SS cranks, weigh about 41 or 42 pounds, which, you know, compared to, like, say, the Datsun Z inline 6 engine, those things weigh like 55 pounds. That's okay, 42 pounds. A Ferrari 308 or 328 crank weighs about the same, but for example, the exact same V8 architecture, but just a more modern design of that, but otherwise the crank is the same size, would be the Ferrari 360 crank. That weighs a full 10 pounds less. It weighs like 32 pounds. And it's the same bore spacing, everything's the same. So that just shows you how much the lighter components were. So the rods that I'm using for this build they fit another engine. They're specifically for another engine. They are readily available, which is why I went with these. And I didn't want to have custom rods made because I was offset grinding the crank anyway. I won't tell you specifically what they're out of, but they are readily available, much lighter, much stronger. The engine will not fly apart with these. And it also allows me to use a really sturdy race grade bearing, a hardened bearing in here. And you just, you know, even if you're doing a stock rebuild on one of these engines, you can't get a race ready bearing, a really stout bearing. You just can't. You just get a regular whatever bearing and you put it in there. But these, race bearing, great. I've already filed down all the rings for the pistons. I've got everything, all the rings here clocked and ready to go. I had these made by Ross, again in California. Everything's out of California that's for custom engines. I won't tell you too many of the specifics on the dome design. I don't want to give away all my secrets here because a massive amount of work went into these. But I will tell you that the dome volume of the SS engine on all of them that I've measured is usually right about 90 cc's or 89 cc's. And so we've got an 82 millimeter stroke and a 92 millimeter bore. You guys can figure out the rest from there. The camshafts that I've had done, this is a custom grind that I've had made for this engine. And the lobe is, so I'll give you an example. The SS camshaft lobe is about, the intake lobe is about 233 or 234 degrees duration at 50 thousandths, and the lift is about 450 thousandths. Or no, excuse me, the lift is about 430 thousandths. The valve clearance that the stock SS cams runs is about 12 thousandths to 14 thousandths. That's the range. I believe it's about that. These are, they're hotter than that. There's got more lift, more duration. Not too much though. It's still very streetable, okay? I didn't want to make something too racy. Now, the engine that I built for myself, I use quite a bit hotter cams in my engine, also because I'm using a much bigger intake manifold. I'm using Weber IDA, 48 IDAs, whereas this will use 44 DCNFs. We've got our chains ready to go. I highly recommend Reynolds Synergy chains. They just do not wear out. They do not stretch. I mean, a little bit, but not much. The SS heads, the intake port is about 36 or 36.5 millimeters, okay? The intake valve is 47 millimeters on these, okay? But what I've learned in flowing these, because I have had these on a flow bench, is that these are exhaust limited. The stock exhaust port on this is the exhaust side. The stock exhaust port is also 36 millimeters. But there's a ridge here, okay? And the ridge, from what I've learned on it, really inhibits flow above what would be starting at 5,500 RPM. So I've opened up all these to 38 millimeters, and you no longer hit a wall at 5.5 or 6,000 millimeters, or 5.5 or 6,000 RPM with these. These will flow, and with these cams and with that compression, these, I recommend a red line somewhere around 7,000 or 7,200 with these. That's where they make power to, and it's a very streetable motor. Yeah, I've got all our gaskets here, and we're over here to the oil pump. The oil pump is driven off a tiny spline shaft that sits in the crank, and you press this, not press, but you insert it to get it in there. And it's an absolutely massive oil pump. This oil pump is way too big for a tiny V6 engine, but I'm thinking LVFERRARI just had it, so he said, just throw it in there, it's fine, you know? And so the cams and everything are absolutely swimming with oil with these, because the cams are the heads are fed by these oil passages here, which come up through the block, and they receive a massive amount of oil. The cams are of course hollow, and oil goes into the cams by this little hole here and that little hole there, and it's hollow, and it squirts it out the bottom of these and into this journal, and oil just goes everywhere. Ferrari cams, Lamborghini cams are the same way. And this is the central jack shaft, which is driven off of the crank. And yeah, so this is basically part one. I just wanted to go over the parts that came in, and you know, sorry if I went and nerded out a little bit too much on some of the specs on stuff, but I just need to underline what's what with these, so I can preemptively answer whatever questions may be coming down the pike on this. All right, I will meet back with you guys once I get at least the pistons inside the block here, and we get that going. All right. Okay, I've got the pistons in here. Everything looks really good, fit together really well. Some things I forgot to mention is these rods, while they do fit something else, I do have to have some machine work done to the rods to get them to fit this. Because, you know, this is a really short V6 engine, and yeah, it's not a whole lot of machining. It's a very simple machining process to get them in there, but they're in. I usually run between 5 to 8 thousandths clearance between the two here. One thing I forgot to mention here is whenever you're putting the cylinder liners back into the block for these things, you have to heat up this whole block to over 300 degrees. I found that a really good spot was about 300 to 310 degrees. And you do it over a lengthy period, just so the whole block gets hot. And then some people like to have these in liquid nitrogen or in the freezer or whatever to make them drop in even easier. I didn't do that. It was plenty. But yeah, this sucker's got to be hot. And it's kind of a nerve-wracking process because, you know, I seal the top here. I got to give a shout out to John Titus, who gave me the trick to use RTV up here between the joint, and I found that works really well. Thanks, John. Kudos. But yeah, I've got the pistons right in here. My pistons, I designed them so that they sit proud of the deck about 14 or 15 thousandths. And I do that on these because I didn't want the dome to, I wanted the dome to be as small as possible to achieve the compression ratio that I'm going for. And the head gaskets that are readily available, I get this kit from Sengali. And these head gaskets are like 2 millimeters thick, which is really thick. I can get thinner ones made from Comedic, which I have before, and I can get them as thin as 1.1 millimeters, really thin. But I like these thick head gaskets. They're really sturdy. But with a 2 millimeter head gasket, that makes for a lot more CC in the combustion chamber that a dome has to make up for. So I have the dome, I have the piston sitting out just a little bit, so that, let's see if I can get it so you can kind of see it. Yeah, you can kind of see it poking out a little bit. Yeah. Anyway, I have that so that the dome doesn't have to be quite so big. This, I haven't measured it 100% yet, but this looks like it's going to be somewhere between 10.6 to 10.8 to 1 compression. I've got to run the numbers again because I wasn't 100% sure how much the piston was going to stick out of the deck. I knew it was going to be somewhere between 10 to 20 thousandths out, but now I've measured it. It's like 14 or 15 thou out, and I can dial that in. But anyway, before I can get this on here and get everything torqued up, I've got to get one more of these because, of course, I thought I had 2, but I got 1. And I've got another one coming. It should be here early next week that I can get this on. And then I can get the chain drive on, which is right over here. This, you'll see, there's a 0 here, if you can see it. There it is. It's got the marking on it right there. And the 0 needs to point straight at the other 0 on the block here. That's top dead center. So I'll have cylinder number 1 at top dead center, and then I'll heat this up in a bath of oil to really hot, but not too hot, like, 300 degrees or so, and then get that on there. And this is what drives everything. And what's shocking with this is there's no keyway or anything on this. This is just, it just fits on here. And it's responsible for driving the jack shaft over here, and the jack shaft drives the chains here, which drive the 2 cams. But on top of all that, it drives the shaft that drives the air conditioning compressor and in the hydraulic cars, all the braking system, the hydraulic system, and drives the alternator and everything. So this thing has a big job, and that's why earlier I recommended the Reynolds Synergy or the Ivis German chain is also really good. But yeah, as soon as that comes in, then I get this nipped up and I can get the rest of this thing together. Oh, one more thing I need to recommend with these is some piston designers, some piston guys, they'll recommend you putting on a low tension piston ring on these. This is another set. These are identical. And they'll recommend something like a 2 millimeter or 2.5 millimeter or even 2.8 millimeter oil control ring. And I've seen this on Porsche engines as well with Porsche pistons. Like JE makes this a standard shelf stock piston with a 2.8 millimeter oil ring. It will burn oil if you have that size ring on there. You need, in my experience, what I've seen is you need at least a 3 millimeter standard oil tension ring on there. I like NPR rings. And I also like Male's rings as well. And, you know, you just don't want to have an oil burning engine. You know, if it burns more than a quart every, 400 or 500 miles, I think that's just too much, and new from the factory, all these Mazda, Ferrari, Lamborghini engines, they all burned a quart of oil. Depending on how hard you drove it, they burned a quart of oil every, 400 or 500 miles. And that was using Victorian era, oil control rings that didn't seem to do a whole lot of any. I mean, they worked, and they were huge, but with modern technology, you want to just be able to button the thing up and just forget about it until you've got to go for an oil change. But yeah, I'll report back once this other silly thing comes in and I can start getting this guy on there, and then the rest of everything should go together pretty quick. All right.